As most of you know, at the Freshwater Fisheries Lab, we've been developing tools for prioritising riparian tree planting for the last 6 or 7 years. And these tools have been sort of developing and changing over time. And indeed, we've just released some brand new tools just in the last 6 months or so. What we found has been happening is lots of people have been getting in touch with us to talk about the tools and how to use the tools. And there's been a lot of sort of common threads among the communications that we've been getting. So we asked Sean if we could get this slot today, basically to give you an overview of exactly where we've got to, and then also to basically take questions from you and to just generally talk about the stuff in general without sort of repeating it across multiple forums. So the way we're going to work this is we've just got a sort of half-hour overview of all the tools that Faye is going to provide. And then after that, we'll open the floor to discussion and any questions that you've got. And we've got another half hour there, hopefully available for questions and anything that you want to ask us about the tools that have been developed so far. So just to make some progress, we'll hand over to Faye. Over to you, Faye.
Thanks, Iain. Yeah, so I'm going to give a quick overview of everything we've been working on over the last few years. And I've got a screen over here, so if you see me not looking at you, that's why. So yeah, as Iain says, we've been working on this for a number of years, and I think many of you are familiar with a lot of the work that we've been doing and indeed been involved in the Scotland River Temperature Monitoring Network. So just as a bit of background is, well, we know that river temperatures are really important for cold water adapted fish species like Atlantic salmon, and increasing river temperatures are a threat. An analysis we completed in 2018 estimated that around 69% of our rivers experienced temperatures that exceeded the limit for thermal stress in juvenile Atlantic salmon, so 23 degrees, and for 1 or more days over that summer. And the UK CP18 climate change projections suggest that summers as hot and dry as 2018 could become as common as every other year by the year 2050. We also know that riparian woodland can reduce high temperatures and is one of very few management options that are available to us. But we know that the effect sizes are highly variable between different areas, different years, that the trees reduce incoming shortwave radiation, and they also reduce heat loss through evaporation and net long wave radiation. A preliminary GIS analysis that we completed suggested that only around 35% of our rivers are protected by any substantial tree cover. And we know from discussions with people like you that new woodland creation can be quite costly and logistically challenging. So really, we're needing tools that will let us target effort to locations where we're going to get the greatest benefit. So say, for example, rivers that are hottest, rivers that might change the most, and areas where riparian tree planting will have the greatest effects in terms of being able to reduce the river temperatures. To answer those first two questions, we have the Scotland River Temperature Monitoring Network. Many of you on this call are involved in the Scotland River Temperature Monitoring Network, set up in around 2014, a strategically designed national scale quality controlled river temperature monitoring network, around 223 sites across 13 catchments. And indeed, we do have some more short-term deployments now being deployed in additional catchments. And what the strategic design of this network has allowed us to do is to build models to let us make predictions of river temperature to locations where we don't have river temperature data. So we can use what we term kind of proxies for processes. So characteristics of rivers that we know influence the temperature of those rivers. So using the air temperature on a given day, and characteristics such as the elevation of the river, its orientation, and the amount of woodland on the banks of those rivers. And those models let us make predictions for any river in Scotland on any day of the year, and that gives us a management tool. So we published the model of daily maximum river temperatures 2018 it came out, and this gave us our first two layers. So a summer maximum temperature of where's hottest, and a layer of sensitivity to climate. So for a 1 degree change in air temperature, what would you expect the change in river temperature to be? And these were the first layers that were published on firstly in that paper, and then also onto NMPI and as web-based mapping services. So I think many of you have already seen these layers in NMPI. So we've got the predictions from the paper. We also then have the predictions for the hottest year in the last 20 years at the time of publication, which was 2003, our where is hottest. And then we have our predictions of temperature change, and these layers are still available for use. Now, based on feedback, I think from a previous SFCC biologist meeting, actually, it became clear that what people were really wanting was a layer that combined both of these results and gave a kind of overall prioritization. And so later on in 2018, we produced our first combined layer, which was called the management priority layer. And we know that a lot of you are actively using this layer to make decisions. But what we would suggest now is that this layer is superseded by our most recent published layers. I'm going to talk about those in a little bit more detail and further on in this presentation. The next question we had in those kind of first three questions of how might we kind of strategically design and prioritise where we're going to plant trees was what we kind of termed planting potential. So where would you get the biggest temperature reductions from planting trees? And we know from process-based modelling studies how trees can influence the energy and heat exchange processes, but monitoring all of these processes is quite expensive. You need kind of automatic weather stations with energy budget equipment on them. The models themselves are very complex to fit and aren't really readily upscalable to anything more than a kind of reach scale. So really what we were wanting to do is to take these really detailed process-based models and say, well, can we do something at a bigger spatial scale? Can we kind of come back again to these proxies of processes, things that we can generate at large spatial scales to let us get predictions at the scales at which people are making management decisions, so their catchment scale or at a national scale. And so we know from kind of hydraulic geometry studies, kind of things like the water volume and the mean column velocity, which are really important for thermal regime, vary systematically in space, so can be kind of captured by things like your Strahler river order. We also then know that things like channel width also vary across space. And things like our channel orientation, aspect and gradient are also really important for influencing the amount of energy receipt you're getting into your river at different times. And of course, you also then have any trees that currently exist in their height, their location and their density. So what we did was we took all of this information and we produced a kind of simplified process-based model that looked at just the energy gains that you're getting within a given river reach. And at a kind of basic level, you can think about this as we had lots of different characteristics of rivers that we set up, so lots of different widths and amounts of water and orientations. We then had a simulation for a unshaded scenario and a simulation for shaded scenario. And if you minus one from the other, that difference gives you an shading effect from your trees. You can then use your information on your amount of water and how long that water is resident in a given reach to give you a kind of temperature difference. And you can then translate this temperature difference into an overall prioritization or ranking score to let you again produce a spatially extensive tool for where you're going to get the largest benefits for planting trees. And that's what we published at the tail end of last year when the paper came out. So this is what we deem the kind of tree planting prioritization layer for shading rivers. So this is purely looking at if you plant trees on the banks of a river, how much change might you expect to see? And because we're only accounting for kind of energy gains, we've translated this score into a scale that runs kind of 0 to 10, with 0 being a low priority, so no temperature reduction, and 10 being a high priority with a large temperature reduction. Now, when you're considering where you're kind of planting trees to protect rivers, you have some decisions to make on your planting location purely on where you are on the banks of those rivers. So can you plant both banks? Can you only plant your southerly bank? Can you only plant your northerly bank? And that's why you're seeing kind of 3 layers for this tool available on NMPI. A layer for where you can plant both banks, where you can only plant one, and when you can only plant the other bank. And these layers are available for use now too. So we've got our where's hottest, where's going to change the most, and where will trees have the greatest impacts in terms of temperature reduction. So we now come on to, well, how do we start to combine these criteria to give us a single overall prioritisation tool? We know that the layers can be used individually, and indeed we have published these as they've become available. And we know from consultation with people like yourselves that ideally a single tool that can be used to kind of answer all of the questions in one is desirable. Now, there's numerous ways in which you could choose to combine these different layers and choose to present them and scale them, depending on what your kind of specific objectives are. So what we're going to do now is just walk through the decisions that we've made and the tools that we've made available that we think are going to be useful for you making decisions on the ground. So at a high level, we've got our 3 tools. We've got our maximum temperature, where's hottest, our climate sensitivity, where's going to change the most, our planting prioritisation, where we get the largest reductions in temperature for planting trees. And we took the results of each of these layers and we generated kind of 20 equally distributed groups across the range of values that we were seeing. We then took these groups and kind of summed them up, divide them by 3 to give us an overall theoretical range of 1 to 20, which we've termed our Riparian Woodland Prioritisation scores. Now the scaling of this would be kind of 1 would be seen as a low priority. So you've got a low river temperature, a weak sensitivity to climate, and a small reduction in temperature or no reduction in temperature if you were to plant trees on the banks of those rivers. And then conversely, your 20 would be high temperature, highly sensitive to climate, and a big reduction in temperature if you were to plant trees. And again, because of the decisions on where you actually plant those trees on a given river reach, we've got three layers for both banks, east-south banks and west-north banks, depending on your orientation. And this gives us a kind of national scale picture of where you might want to prioritise planting trees. Now, of course, we know that quite often people or organisations are working within this particular area of interest and focus. And often there is a desire to know, well, where in my area of responsibility am I going to get the greatest benefits of planting trees, and how might I target my resource at this smaller spatial scale? So those of you with really good memories will recall that in our national river temperature model, we have a hydrometric area spatial smoother. So because we have that within that model, we made the decision that we could take our hydrometric areas across Scotland and rescale these overall results to give us a theoretical 1 to 20 score within each of the hydrometric areas to give you something that better illustrates the spatial variability and planting potential at these smaller spatial scales where people are still making management decisions. So we've got our national scale Riparian Woodland Prioritisation scores, and this lets you have kind of comparisons across all of Scotland. And we then have our locally scaled Riparian Woodland Prioritisation scores, where we have the results scaled to within individual hydrometric areas that can be then used locally to target within river systems. But critically, you can't then compare between river systems with this tool, so between hydrometric areas, I should say. So what this has produced is our Riparian Woodland Prioritisation scores for Scotland, and we've got a nationally scaled and a locally scaled, and we also have the tree planting options of being able to plant both banks, being able to plant your most southerly bank, and being able to plant your most northerly bank. So this results in kind of 6 additional layers that are available for use. The scales go 1 to 20, 1 low priority, 20 high priority, and this is the tool that we would currently recommend for anybody prioritising kind of tree planting that's wanting to account for where's hottest, where's going to change the most, and where am I going to be able to have the biggest impact in terms of temperature reduction from planting trees. So how do you go about accessing these tools? And I'm conscious that some of my GIS colleagues are on these calls, so hopefully I'm going to get all of this correct. The key first starting point is going to the Scotland River Temperature Monitoring Network web pages. All of these web pages have been updated in the last year. And we've also updated them to include specific instructions on how to use NMPI and also how to use web-based mapping services in whatever GIS environment you're using. So ArcGIS, QGIS, R, whatever you might be using. So the Outputs and Tools webpage is the kind of key starting point. If you're going from the web pages, each of the layers has a direct link to the NMPI layer from the web page. So if you click on that link, it will open NMPI and it will show you the layer that you've chosen. If you're accessing directly from NMPI, or you've opened one layer and you want to open an additional layer, you can readily add in any layer from NMPI, whether it's the Scotland River Temperature Monitoring Network or any other layer that might be of interest. You go to the Add Layers tool, which is highlighted here with this red circle. You'll then get a list of different sections, and all of the Scotland River Temperature Monitoring Network are housed under the climate change section. So you kind of click on the section, it goes green, and then it opens all of the tools that are available for those layers underneath. And you click on the tool that you're interested in, you'll see the green tick, hit the add or remove layers, and then it will appear for you on the NMPI page. You can also then view the legend, and you can get access to the metadata for those data sets as well, so a description of what you're viewing. Now, if you want to use a WMS layer, so those of you that aren't familiar, is a WMS layer, so a web-based mapping service, can be kind of considered as a geo-rectified image, so an image that has kind of spatial data associated with it. So you can pull it into your own GIS environment. So for example, you can pull it into ArcGIS, you can plot it up, you can zoom around, you can overlay your own spatial data. I know that many of you have really quite detailed local GIS data on, say, where you're currently planting trees or where you might be targeting in the future, maps of kind of landowner permissions, things like that. So you can bring in the WMS layer and you can view that alongside any other spatial data. So again, the links to the WMS layers are available via the Outputs and Tools webpage. When you click on those links, it sends you through to the spatial data at gov.scot. This is where kind of all of the metadata for the WMS layers is housed. So you get a description of the layer that you've selected. And if you scroll down the page, you get to the downloads and links section, which provides you links to the maps on NMPI again, but also the links to the WMS layers. So what web link you need to kind of copy into your relevant WMS section, as it were, of whatever kind of GIS package you're using to allow you to pull that layer into your GIS. So to conclude, we know that river temperature is important for salmonids, and we expect that it will become an increasing problem under climate change. We know that riparian woodland can reduce river temperatures, and we have these tools available that can be used to target constrained resources in terms of management action. We can scale these at national scales and regional scales, or scales depending on your objectives. And it's also possible to combine these with other tools. So combine them with your own spatial data, or also more formal tools. So some of you may be familiar with the spatial multi-criteria analysis being completed by Alessandro Gamoa at the James Hutton Institute, which is looking at how to prioritise tree planting across all of Scotland, using lots of different criteria, but also including things like riparian woodland. And we're actively working with Alessandro in integrating the Scotland River Temperature Monitoring Network layers into this tool that he's developing. So that's a kind of quick whistle stop from me. As Iain says, we've got plenty of time for questions now. So I think Iain will join us and be kind of fielding those questions that both of us can kind of answer.
Great, thanks.